Hello, folks. Welcome. How's everyone doing? I see some of you have already found the chat box, which is excellent. Feel free to drop in your name and or where you're from. I love hearing from where potential students are from. It's a beautiful day here in Chicago, so good morning, or good afternoon, good evening, wherever you might be. Silicon Valley, beautiful. North Carolina. That's great. Canada, that's awesome. Well, they're all of them are rolling in now, so which is great. So thanks for sharing that. We'll get started in just a minute here. I want to give folks some time to get in and get settled a little bit. In the meantime, if I want to talk a little bit about how to participate during this session. So if I'm going to go to the next slide. Okay, here we go. So down here, you should see in the Zoom meeting the Q&A box. So there's also a chat, which many of you are participating in, which is fantastic. See a fellow Chicagoan, which is great. Couple Chicago folks, which is awesome. So if you have a question during the webinar, as I'm going through it, go ahead and fire away into this Q&A box, and I'll definitely get to it. So sometimes in the chat, when I'm doing this, it can get a little busy, and I don't want to lose your question. I can usually do a pretty good job of both, but again, if you use the Q&A box, I'll definitely get to it. I have some support on this call too, so if there's any questions around admissions or anything like that I don't know, I know the content very well, but there's also a support team on here that's assisting me too. So fire away all your questions in the Q&A box, and we'll be sure to get to them. Can you record this? Yes, I believe this is being recorded. I believe. Yep, it is. I see a little blinking record light on my screen at least. And so I believe if you've signed up for this, you should get the recording afterwards. Okay. So it seems like we've, achieved critical mass here. So we can go ahead and get started. So again, welcome to the Emeritus webinar about our Applied Machine Learning and AI class with Columbia Engineering. I'm going to be talking about a few things, but first I want to introduce myself, or I'll go over the agenda actually. So this is what I'll be covering today. So I'm going to introduce myself and some of the folks that run this course, talk a little bit about Emeritus, the programs that we offer, and what we do, and then dive into the course specifics. So we'll give an overview of the course, your learning journey, what you can expect throughout the course, and the experience that you should expect to how to learn. And then we'll finish up with some Q&A. So that's the game plan. So to kick things off, I'll introduce myself. My name's Carleton. Again, I live in Chicago. I've been an educator for about 4 years now in total. I've been with Emeritus almost 2 years. But I've originally, I work currently at United Airlines for now. We have kind of a tough time right now, but still with United Airlines, doing some data science and analytics with their operations team. And I also work with a number of different educational institutions. I started off with General Assembly, teaching their data science and Python courses. And like I said, with the last 2 years, I've been with Emeritus doing some design work, and also with particularly this course, I've been heavily involved with applied machine learning and artificial intelligence as a course leader in that capacity, and also in some of the design work. So, so I love teaching. I love working with students. One of my favorite things about students is seeing everyone. I was once, I was a student. I have a master's degree in predictive analytics from DePaul, and before that, I was a business school guy. Went to Indiana University, got my undergrad in business, and had a career shift because I decided that I wanted something a little bit more with hard skills, and so got into data science, and the rest is history. But I do love working with students because I was once in their shoes. This was all new to me at some point, and I love helping people through this journey. So I'll talk a little bit about the faculty at Columbia Engineering. So Professor Paisley is over here on the left. He does quite a few of he does all of the videos for the applied machine learning, which I'll talk about in a second. Professor Ansaf Ayusi is the professor that you'll use, or you'll see doing a lot of the artificial intelligence webinars and the lessons on that. So here are the two faculty. They're excellent, very knowledgeable, and they do most of the lecture content of the course. There's also, throughout the course, course leaders. We call them course leaders. And of course, I've already introduced myself, but there's a number of other ones. All of these folks I've worked with before, and they're excellent course leaders, very experienced, and they have either participated in this class as course leaders for a while now, or have contributed to some of the content that is delivered. And so they're all very, very experienced and very knowledgeable team. So I can speak to that personally. So the course leaders. I want to talk a little bit about Emeritus now. So this is a little bit about Emeritus. So we are a global organization, which is one of the strengths that we have. I love that when I do these webinars and I do even the classes that I teach and that I support, I always love hearing about where everyone is from, because there's people all over the world. It's littered all over the world. It's very fantastic. So so we partner with the best universities in the world and create online courses to deliver them, in an effort to make education more accessible. And we've created these online courses, and we served by now. I started almost 2 years ago, and we've served almost over 50,000 students from across the world, which is a pretty staggering number. But what's nice about this is that when you join Emeritus, you're entering in a global network of individuals that have been through this program, that are also working in data science or a related field, and you have those network available to you to connect with and make relationships with. Okay, so this is a little bit about the course itself. So, and just how we design courses here at Emeritus. So we have a number of different components that we try to give you learning in different modalities. And so there's a number of different, in the bite-sized learning piece over here, for example, the lectures that you receive are a lot of, they're really short, trying to be to the point, but also have enough depth in there to provide you the learning opportunities and giving you examples. So there's, it's the bite-sized learning so that you can take each topic in its own vacuum and look at it and provide the presentation of the material in a small modular way. And so also bringing it back to previous examples. But this bite-sized learning is kind of helpful, because sometimes you don't have time to sit down for 3 hours straight for a lecture, right? So these short 10 to 20 minute lectures talk about what the content is, and they all connect with each other. But that's generally the format of what the lectures are bringing. So the content that is delivered is from these leading academic institutions, like, for example, and this is the Columbia Engineering. And so I talked about the faculty before, but also where the magic happens, in my opinion, when excuse me, the students start to connect with each other. That's really where you start to learn a lot. And so we have a learning platform that we use called Canvas, that all of the assignments and the lectures and everything is delivered through this one centralized portal called Canvas. And you can also connect with your fellow students on there. And so you can hear from a lot of different, there's a lot of more, usually when we're teaching a subject, the content is the same, but there's usually more than one way to get there. And so it's always interesting to me to see how students approach problems, and depending on their backgrounds, you have a variety of different backgrounds from very different places. And when the peer-to-peer connecting happens on the discussion board, that's really where I see a lot of the light bulb moments occur. So there's also guest lectures I'll be delivering throughout the course. There's a number of different webinars that we provide. So in addition to the lectures that the Columbia Engineering faculty give, we also as course leaders deliver webinars on special topics just to reinforce the learning. So there's also part of the completion is to finish out the grading. And so you have these assignments that are designed to augment the lectures that are delivered. So the lectures provide the theoretical and the background on the actual topic, and then you're expected to pick up the assignment for that week and actually apply what you've just learned. And so you have to get your hands on the keyboard and code out what you've just learned about. And so that's really where a lot of your time is spent. You follow the lectures, but actually doing something is a totally other thing. So it really helps to connect with peers and having that group learning occur, and also being able to apply what you've just learned. So there's one more thing I wanted to say, but it's escaping me now. So, oh yes, so the course is based on completion, and so we have a fantastic completion rate because we actually make a strong effort to make sure that that you can get through the material. If sometimes it's a difficult course, right? And the assignments are built in Python, and all the content is about machine learning and artificial intelligence, which are by themselves topics that are difficult, right? So if you're new to Python, or if you're experienced in Python but you're new to machine learning, maybe just learning one of those things can be difficult. If you're learning both at the same time, it can also be a little bit more challenging. But we do our very best to reach out to you to make sure that you're on pace and that we're very much engaging with you, to make sure that you complete the course, because that's really what we want, right? So lots of support. So I mentioned the network a little bit. There's actually a formal program. It's the Emeritus Network. It's a platform that is exclusively available to all Emeritus alumni and whoever has successfully passed any Emeritus certificate. So by going to this program, you instantly have some sort of connection, whether it be on LinkedIn or even more of like a stronger connection, like you actually can reach out to and engage with people. You instantly get plugged into this network of folks that have been through this program and share the same interests as you. Depending on what your goals are, many of my students are looking for some sort of career shift. And so this is a fantastic way to connect with other individuals that are in industry practicing it, or in academia that are doing machine learning and AI, using it in their jobs. And so this is a fantastic way to connect with them and learn about their experiences and what they use this stuff for. And this is really the best way to achieve some of those outcomes that you might have. So different students have different goals. Some just want to level up in their skill set. They might not be looking to change careers. Others might be looking for like a big shift. Some are just curious and they just like learning about this, so they don't actually have any outcomes and goals. But I do encourage you, if you decide to move forward with this, is to take advantage of the network, because it's a very, very strong piece of what we provide. Okay, I'm not seeing any questions so far, which makes me suspicious. Okay, so yeah, go ahead and as I'm talking, go ahead and fire away in the Q&A box. So happy to stop to talk about anything, but we'll just keep plugging along. Okay, so let's talk about the actual course now. So this is the so AI and machine learning. We talk a little bit about this at the beginning of the course, of kind of the why, and but more and more AI and machine learning, data science, are becoming a little bit more democratized in industry. And so what I mean by that is we're starting to figure out now, like I'd say that the wave of data science really picked up steam about 10 years ago, and maybe 15 years ago. But there still was a struggle within businesses to figure out like what really is it, and how do you actually identify use cases and apply the right framework to those use cases to be able to really leverage data science to bring business value. So it's really easy to get caught up in the machine learning and data science metrics, but bringing those back, translating machine learning metrics back to the business metrics is sort of a difficult thing. And so you want to make sure that you can understand that to be able to communicate to some decision makers that are actually care about the bottom line. So, or whatever you might be in. So if you're in government and you're in public health, it's not always about the bottom line, but there's many use cases where data science can succeed, but if you pick the wrong data use case, it's easy for it to fall apart. And so more and more there's becoming more better understood, but also there's lots of tools and languages and algorithms out there that have sort of emerged to help us do this. And perhaps as far as languages are concerned, Python has really been adopted by the data science and the AI community as the preferred language because there's some really smart subject matter experts that have contributed to these tools and developing them at scale too. So there's PySpark, there's Python is what we focus on in this course because it's it's probably the most ubiquitous language used for data science. There's also others, of course. There's R and there's SAS and that sort of stuff. But Python is open source and it's one of the more popular ones. There's also the parts of the AI which are the principles and the techniques. So these are more like the methods of how to apply these things. So I'm talking neural networks here. I'm talking like ensemble gradient boosted trees. Some of the even linear regression, logistic regression. These are some of the techniques that you learn about of how this is more of the mechanics of like how you solve the problem. The first part is to identify the problem. You get your data, and depending on the situation, you apply the right technique. But you have to be able to apply it. So you have to know the code to be able to implement the problem. So you have to know what the algorithm is. You also have to know how to use the algorithm and code and implement it, deploy it. And that all comes with this hands-on experience. So we provide a number of different assignments, and we also have a number of exercises that are based on industry problems that we provide to you to get you thinking and using and experimenting with these things. And then there's also the career resources that like the network, the Emeritus network being an example of this. This is sort of geared toward the folks that want a specific outcome. So in your career. So once you have all of these together, you're ready to go and you're ready to join, get a job in AI or start using AI in your job to solve problems. That's really what we do. So got a first question, which is awesome. Question is asking, does the program include some healthcare related work problems? So we do have like some data sets that we work with that talk about this, but there's not like there's not like a specific assignment. I don't think that's explicitly for healthcare, or it's more of like a general. We try to give exposure to a lot of different areas, and for the machine learning part at least, we're trying to, and the AI section, we're trying to give you exposure to the actual how the actual method works, and then we apply it with some code. And so this has some implications in healthcare, but it's more focused on the machine learning and the data science and aspect of it. It doesn't have, it's not all around healthcare. I have some experience in my career with, and when I was in research before I started, when I was in grad school, I used to work with some, there was radiologists that did some work with identifying lung nodules and detecting if it was a malignant or benign tumor. So, but there's a little bit of that in here, but it's not this, I wouldn't say it's the sole focus. So that was also an excellent question here. I see perhaps jumping the gun here, but what's the difference between machine learning and artificial intelligence? So there's a very fine line, I'd say. So let me ask that. So it's not a fine, it's a blurry line. So Machine learning, when I refer to machine learning, is I'm mostly referring to a oh man, I'm trying to think of the best way to put it. So it's like, think of linear regression if you've faced that before. You have some data set and you're trying to train a machine to predict that and to predict whatever it is, your stock prices or whatever it might be. And so the machine learning part, I'm referring to more as around the algorithms themselves. These are different algorithms that learn and can predict things for you. Linear regression, neural networks, like ensemble-based learning. So these are all machine learning algorithms. So that's kind of like the suite of machine learning is like I'm referring to as the algorithms themselves. Artificial intelligence also sort of blurs that line. To broadly explain what artificial intelligence is, I'll just say the simplest way I can put it is that when an artificial intelligence is training a computer or a machine to do a task that is normally performed by humans, right? So that can be, think of like Alexa app, right? You have there's some sort of model or models behind that you say something and then it replies to you. It used to be that was only a task that humans could do, is converse and conversation. And so the line of the realm of AI is always changing, right? Like speech to text used to be considered an AI application, but now it's so common that, and it's really outside of that now. So it's not like it's a moving target almost. So, okay. Another question here. How many years has Emeritus Columbia offered this program? How many students are enrolled in this program? I don't know how many students are enrolled in this class right now, or the upcoming one in June, but I know as far as I think I've been involved since actually the beginning of this course, which is almost 2 years ago. So we've had several iterations by now, worked out the kinks. And so I've done this class probably, I don't know, 6 or 7 times. So yeah, I couldn't tell you how many are enrolled right now though. So what is the course for? Is it for beginners, intermediate, or advanced? I'll say that you should have at least some familiarity with Python and some statistics in linear algebra. There's going to be an assessment, which I'll talk about in a bit, just to see where you are. But going into it completely new to Python and completely new to stats and maybe some machine learning, you don't have to be an expert in machine learning because that's what you're going to be learning. But you definitely need a little bit of understanding of linear algebra and statistics. And I would say it's probably for intermediates in those areas. But if you're completely new to Python, like maybe like machine learning, then it might be a good fit if you have the Python background and you don't have to worry too much about figuring out how that works. So I don't know if that exactly answers your question, but it's definitely, by the end of it, we cover some of the more state-of-the-art algorithms and that there are out there. So it's definitely not intermediate. I'd say advanced at that point. By the end of the course, we're covering very advanced topics. Can you talk about the capstone? Absolutely. Let me put that one in the parking lot. When I get to the section here that talks about course specifics. Okay. And then also about examples of how someone's used the program to advance their current career and who have changed careers. Okay. Yep, sure. So I'm getting a lot of course specific things. So let me just keep chugging along here. And maybe some of these questions will be addressed to the normal, right, but I'll keep an eye on this Q&A box. So this is how the course is set up. There's 3 modules. So there's the applied machine learning, that's the first one, applied artificial intelligence, and then the capstone project. So the first part, applied machine learning, we cover a lot of the fundamental machine learning algorithms, that some of the more commonly used ones. This includes, it starts off with linear regression, then talks about Bayesian statistics and Bayesian models. That's the probabilistic models. And it dives into some classification models. And so, which leads then into ensembles. And then we talk more about recommender systems. And we touch on a number of different of the machine learning algorithms that are some of the more common ones used. And then in the applied artificial intelligence module down here, a lot of these are, well, I have like a list of all the ones that we talk about on the future slide, but we'll get into those. A lot of them is around search algorithms, heuristic search, adversarial games, reinforcement learning. And then the capstone is where you get to an opportunity to apply all of these things. And so the capstone project is really your opportunity to showcase what you know. And, if you're, depending on what your goals are, you hopefully will walk out of this with a demonstrable piece of work that you can show to people, put it up on your GitHub, show it off, saying, look, these are all the things that I did. And I can prove that I know these things because you can look at it. So that's one of the most valuable pieces of this curriculum, in my opinion, is the capstone project. Okay. So what can you expect? You can expect to spend about 6 to 8 hours per week for learning. That might vary a little bit if you have, a little bit, if it's a little bit more particularly challenging for you one week, or if it's a little easier for you, maybe you've seen it before. Might vary a little bit, but this is in general, on average, about how many hours you can expect per week. So you'll have the lecture videos and the graded assignments and discussions, and then the real world data sets. So those are all the components of each module. And so within the applied machine learning section, you'll learn about the supervised and unsupervised learning. So what this includes is, I named a number of them already, but also what's included in here, in addition to the regression, and classification, and you'll learn about gradient boosted trees and random forest. You'll learn about clustering. I didn't say any of the unsupervised part. So so in case you don't know the difference between supervised and unsupervised learning, what I mean by these terms is supervised learning, your goal is for prediction. I have a data set of features, and I have a target variable that I wish to predict. And let's say, for example, it's Apple stock. Okay. Let's say I have a bunch of, I want to predict the price of Apple stock tomorrow, so I can guide my decision-making on how I behave today. I'm going to collect a bunch of features about Apple that I think are going to be predictive of that price, right? So I'm going to try to capture the function, the underlying function that nature is providing, that we're observing in price, and there's an underlying, we're assuming there's an underlying function that's generating these prices. We want to try to capture those. So we collect features about Apple, like their tenure of their CEO and their last quarter's performance and the certain opportunities that they have right now. What are their their upcoming product things? So we quantify those as features, and we try to fit a model that will predict price. And so since we have those prices, those historical prices that we can look at, that is a supervised learning task. So whenever you see a supervised learning, that means that we have a set of labels and we have a set of features, and we're trying to predict that. Unsupervised learning means that we don't have those labels. So imagine we didn't have the stock prices. We just have a bunch of features about Apple, or let's say a bunch of technology companies. And so the goals change, and unsupervised learning is more about representing this data in a meaningful way, whether that means grouping them together, it's called clustering, or reducing the dimensionality down, collapsing them down, that's dimensionality reduction. So we cover all those topics. And then there's the capstone. On the artificial intelligence side, we have a lot of different like heuristic search and intelligence search, reinforcement learning, hidden Markov models, neural networks. That's the deep learning stuff, and adversarial search and different games. And so those are the different topics that we're talking about on the artificial intelligence. So I want to take a pause here, and at the end, when you complete this, you'll get a certificate from Emeritus in collaboration with Columbia Engineering. So I'll show you an example of that here in a second. So I've seen a bunch of questions swoop through. So let me take a look at these. So this will probably be a good time to talk about the capstone project. So that's the first question I see from Stephen. So the capstone project is fantastic. So what this is, we provide you a data set and a prompt to as a problem. And So the problem is was posed to you, and we give you the data set, and it's up to you to just kind of go. And that you have a goal of whether it's predicting who's going to be a a future client, or it's a specific use case presented to you. But you give the data set and a prompt, and then it's up to you to just go and use the data science workflow to solve the problem. And so you get your data, and usually you'll explore it and you'll discover all of these problems with the data. And so it's just a reality of life as a data scientist, is that you're going to spend most of your time cleaning up the data. And so you'll get experience doing that, exploring the data, so finding interesting relationships between the features and your target variable, and then building a few models and iterating over feature engineering and creating new models that perform the best. And so the name of the game is to get the model that performs the best, but then take that performance and map it to the overall goal, and to communicate to someone in an audience who might not be technical of how that is affecting the bottom line. So that's a little bit about the capstone. I think you might have flexibility to choose your own topic, but most students don't decide to go that route. Usually I think you do have the option, but if you want to do your own project, you need to submit the sample of the data and your, I guess it would be like your problem statement of what you want to do, and a sample of data, just to make sure that you have the data in hand. And then it also fits within the scope. So I do think you have flexibility, but most students decide not to do that. So there's a little bit more work involved in that. But so hopefully that helps with the capstone. Can I provide examples of someone who has used this program to advance their career? So I don't hear a whole lot from students afterwards, but I do love it when I do hear from students. But I've had students that had no experience at all, and they ended up getting into like an analytics and entry-level data science position, and it still works well. I've had students that have gotten jobs in this program before the program even ends, right? So it also depends on like how aggressive you are on that front too. I won't say that is going to happen to you, but by the end of this, you should be, if you do the curriculum, you should be in a position to start your career somewhere. You might not be landing as a data scientist, but you might already be, so I'm not saying that's all across the board. I just don't want to overpromise something, anything that is not, might not be realistic. It does depend on your background, but I will say that we cover everything we cover in this course. Is if you understood everything that we cover in this course, you are more than ready to start your career in data science. So I see another question about AWS or any cloud deployment. We don't touch the cloud just because it's too difficult logistically. Like some of the AWS stuff I've worked in, it just getting set up is not a trivial thing. And so it really causes a lot of frustration with students when you have to, you don't even get to the content yet, and you're just trying to get the machine to work. It can be logistically a negative learning experience. And so unfortunately, I would love to do something with AWS, but no, we don't cover that. How successful has deployment graduates been in finding jobs? Like I have like my own students that have like anecdotal things, but if someone has I don't know if someone has the stats on that, but I'm sure Emeritus has some statistics on job placement. Does Emeritus provide any career support? I don't know if the network might be the best one for that. I know we didn't used to have career support, but I think that's changed. So I can't speak to that because that's sort of outside of my, like I just work with the class. If there's a separate program that's ongoing, I might not be aware of it, but I know that I love working with students. So like when I always encourage my students to reach out to me or friend me on LinkedIn, and I'll introduce you to anyone on my LinkedIn. Like, if you want to get a job, like, I'm happy to facilitate and be your advocate. So another question, would a 60-hour Python course on Udemy be sufficient? That's what you have. So yeah, I think, yeah, as long as you're not going into it completely new to Python, 60-hour Python course on Udemy should be totally sufficient. So you should just know the basics of what's a dictionary, what's a list, how to, take in a string and like manipulate it a little bit. Like you don't need to be, total whiz on Python. Just kind of know a little bit about it is sufficient. Could I share some insights on advanced models that you plan to cover in this course? Yeah, probably like some of the advanced ones are reinforcement learning. There's the A-star algorithm. There's neural networks, which are covered. Those are some of the most powerful and predictive ones that we provide. So, but also, you don't have to they also have their own shortcomings too. So like, neural networks sound fancy and they get all the news headlines, but they also, take a lot of data to train and also aren't all that interpretable. So depending on the use case, it might not be a good fit. And that's one of the reasons why simple things like logistic regression, I use logistic regression more than I use neural networks in my job at United. So because it usually does good enough job to do an improvement on what we're currently using, and it's interpretable too, so we can explain how it's coming to its predictions. But those are some of the advanced ones. Hierarchical clustering from the unsupervised learning part, k-means, those sort of things. Hopefully that was a very small overview of some of the algorithms, but hopefully that helped. So said, which field of application of AI should I opt? Data science, healthcare, big data, image processing, neuromorphic, or any other? What do you suggest? So how do I choose the subject of my career? So that's I don't know if I can answer that, but I'll say that AI and data science has applications in all of those. I would say follow your interest on that. Like, image processing is more of an isolated technique that it can be applied to a broad range of domains. So if that interests you, then you should just go down that route. I encourage you just to follow your interests in this because data science, you'll never know where you end up in data science, right? So there's lots of little different, you could spend your whole career doing natural language processing, right? And that's it. You just live in that world because I mean, if you start going down the rabbit hole in that, it's a pretty deep topic, and it will get paid very well in that industry if you wanted to go in there. So also the same thing with like image processing or just general data science. There's a lot of different offshoots. So I would just encourage you to follow your interests and reach out to folks that are doing things, right? So if you want to talk to someone that does computer vision, reach out to them and see if you can meet them for coffee or tea, or just learn about what they do to see if that interests you. The Emeritus network would be a fantastic place to do that, by the way, because you already have that thing in common. You both went through this program. That'd be an ideal way to make that connection. Next question is, how much data science, cleaning, processing, etc., data engineering knowledge, experience do you need to be successful in this course? So from the engineering standpoint, we're not expecting you to be like a DevOps, engineer or anything like that. So almost everything we do is hosted through our platform called Canvas. So that's where the lectures are. That's where the assignments are. That's where the quizzes are. That's where you'll get all of these Zoom invites that I do my webinars. I do weekly office hours. I reply to people. You can send in support tickets individually to me that we reply to within 28 to 48 hours. So there's lots of support. And I think the knowledge that I think there's a baseline of statistics that you need to know, and maybe some linear algebra. Like, you should know probably how to do matrix multiplication. It's not like anything you have to, you don't have to be an expert in anything like that. Just everything we do in this course is founded on mathematics and a lot of linear algebra and a lot of statistics. So if you're going into that completely new, then it might be a little bit more difficult to ramp up. It might take you more time. But yeah, you don't need to. Certainly, we're not expecting you to be any sort of expert in spinning up EC2 instances on AWS or anything like that. Everything's sort of provided for you on Canvas to make it easy. We want the learning experience to be about the actual algorithms and the coding, not I can't get my Jupyter notebook to load, right? That's frustrating when you deal with that for 2 hours and you haven't even looked at the actual content before. So we provide that all through Vocarium, and so that sort of is taken care of for you. But to summarize that question, I would say stats and linear algebra, and then baseline Python. Those are the 3 things I would focus on. Can we work on capstone groups of 2? Unfortunately, no. The capstones are going to be an individual project, so you can't. It's not designed for group work. What platform do you use for AI and ML? And is it AWS? No. So we use there's a platform that we use within Canvas, which I've mentioned a couple times now. It's actually, the platform is actually called Vocarium. That actually is the server that this is running on, and there's software that grades your assignment, and I can get in there and I can view it. I can look at your work and help you out. But yeah, the Vocarium server is where all of the coding occurs. So that's where the implementations actually happen. But you don't need an AWS account. You don't need anything like that. So I wish to apply AI in trading as an analyst at a hedge fund. Do you have any students who did that? Yeah, I have students that, I don't know if they do exactly that. I don't know if they work at hedge funds, but I have students that work in trading, like options traders. I've worked with a number of them. Like in Chicago, there's the Mercantile Exchange that's here. So I've worked with a bunch of students that do that too. They trade like corn and soybeans and stuff like that. I don't know anything about that. I don't claim to be any sort of finance expert, but yeah, I know that they've taken my courses and they've been able to use some of this in their day-to-day job too. So, which is pretty cool. You mentioned that you have a master's degree in predictive analytics. What are the benefits of taking this diploma versus enrolling master's in data science? So when I started, this was, I think I graduated in like 2016 or 17 or something. I forget actually, but so you'll get a lot of, like, we cover everything in this course that I covered in 2 years in grad school. So for one, there's a lot shorter time, I guess, this route than it would be for going the traditional educational master's degree. Also, it was a lot more expensive to do that route too. So like those are two different knocks on that. Not to say I don't regret my time at all at DePaul in predictive analytics, because I also made great relationships and things. Like really happy where I landed. But this program is also excellent. I didn't know about this. This program didn't exist at that time. But yeah, so like the perks of this are you get education from world-class, University of Columbia engineering, and you also get to apply a lot of the methods that when I was in grad school, it was a lot of looking at a screen with a bunch of Greek symbols and numbers and math symbols on it. And there really wasn't hardly any focus on the code. There was some, but that was sort of left to your own. And so there's a lot more applied data science and AI and machine learning in this course, I'd say. That's the major difference. How much does postgraduate diploma by Emeritus weigh in compared to, say, a master's offered by Berkeley? I'm pretty sure we work with Berkeley. And so, but I don't know. I think it probably depends on who you're applying to. So I think one of the nice things about this program, though, is that you get to, from a traditional academic setting, in my experience, there's from like the research world, there's a lot of focus on the algorithms themselves, how they work, the mechanics of them, how do we do tweaks to them. Not so much, you didn't really care about, is it practical to use this in a business setting? And so that's sort of more of the focus here. With the lectures are definitely, some of them are theoretical, because you have to learn that. You have to learn that content, but it's also more important to know, okay, this is how it's done in the real world. So that's where the assignments come in, the real world data sets, the decision exercises. And so, and the capstone project is, you can walk away from this class with demonstrable work that proves that you know how to do these things, because you can show it. You can show it to someone that you've done it. So those are some of the things that I think are really nice pieces of this curriculum that round it out well. Okay, cool. So here's some examples, partially on the slide a little bit earlier, but here's some examples of the assignments. So there's a movie recommendation engine that that takes a couple weeks, because that spans a couple weeks of content. There's housing price predictions, there's credit card fraud, market segmentation. Here's some of the examples that we cover in the assignments of what you'll be doing. As far as the learning experience, I think I've spoken about it a lot. But here's the actual slides on it. So there's Canvas, the platform's called Canvas. And so we also have, in addition to the quarterly lectures that you'll see, there's course leaders like myself do weekly office hours every week. For my office hours usually run over. I should probably be better about that, but like I get talking, and so they run over a lot, not always, but and we also provide periodic webinars that give a deeper dive on specific topics like intermediate classification algorithms or Bayesian regression, that sort of thing. So you have those, and then the assignments, and then the peer-to-peer learning discussions. So learning facilitators like myself, the course leaders, also provide feedback to you. We can answer your questions through Canvas. There's also a support tab. You can click and send me a message, and I'll reply to you within 24, 48 hours. You can also send me an email, and I'll get it that way. So there's lots of opportunities for you to reach out if you need help. And there's also the discussion board. I find that a lot of students like using the discussion board to get feedback from their peers. Okay. So again, here's a quick summary of what to expect. There is these modules that you'll be using to learn some of the content. Spend 6 to 8 hours over 9 months a week on average. And you'll have assignments, quizzes, peer-to-peer learning discussions, and webinars. And you'll frequently hear from me, especially if you attend my office hours every week. So the admissions process, I want to get to this. So you'll fill out an application. I don't know a ton about this process, so if you do have questions, fire them into the Q&A box, and the team here support me. They'll be able to address all of your questions. But this is in general the process. You fill out the application. There's some documents you have to fill out and submit. There's application fee. There's a pre-admissions test that you have to pass. All right. So this is just to make sure that you are at an adequate level of understanding in some of like the fundamentals, like statistics and linear algebra, so that you can get the most out of this class. What I've found in the past is when students join and they don't have the needed prerequisites, they get behind really fast because the course moves quickly, right? It's 1 week we're talking about linear regression, the next week we're talking about Bayesian regression, the next week we're talking about something completely different. And it's really easy to get lost in that, especially if you come out of the gate a little bit behind. And so that's what the purpose of this admissions test is. And in those cases, the students usually get frustrated, and it's not a great learning experience, and we want to avoid that. We want you to get the most out of this class as possible. So that's what this is designed for. And so I'm happy to talk more about that. So this is more about the test. So after you register, you'll be given a set of sample questions with answer keys, and to assess your familiarity with calculus and linear algebra, statistics, probability, that sort of thing, and a set of learning material. And then, whoops, I didn't mean to do that. So after doing that, you receive an email with details on the admissions test. So you'll have 2 attempts to get 7 out of 10. That's the goal. So if you score 7 out of 10, you're in a good spot to take this class. And so you're good at that point. If you don't score 7 out of 10, we realize that some people have certain situations going on. So if you don't, you just have to contact your program advisor to work with them for further details. But there's really not, so yeah, at this point, we're not going to say you can't get in, but like you just have to contact your program advisor, right? Because it's a little bit more like an individual case by case basis at that point. So want to make a second to check the Q&A box to see if I have any questions here. So see that Emeritus, let me see if there's any. So why do we pay and then do the test? What happens if we fail for the test? So I don't know that one. That's a good question, but I feel that you will get a refund. I'm trying to go backwards. Here we go. Okay, so the application fee, yeah, I don't know how much that is, but you definitely don't spend any tuition before you take the test. There might be an application fee. So let's go to this. Okay, yeah, there is an application fee of $50 to apply. So, but as far as tuition is concerned, it sounds like there is, before you do that, you'll have to go through the test. So the pre-assessment test. So the diploma fee is $3,000 US. So here are the prices. You can pay in 2 equal installments. So this is a part of the course I don't really know that much about. The finance side, really just deal with the content mostly, but happy to address any of the questions that you have about this too. So that's what the other folks on the call are here to help me out with. So I see questions too from Stephen. I see that Emeritus also offers similar courses in AI and machine learning. By taking this course, do we not need to take others in terms of augmenting our knowledge in AI and ML? Yeah, so if you take this course, I don't know all the course offerings that Emeritus offers in terms of data science and AI and machine learning, but I know a lot of them. I know all of them with Columbia. I would imagine that there's a ton of overlap, right? So I don't think you would probably need to take more than one machine learning class unless there was a class that you were looking at that is highly specific, like this class is about computer vision, right? Then yeah, that's probably going a little bit deeper into that particular topic. But if it's just a broad machine learning AI course, I don't think you don't need to take 2 classes. This class covers everything that is probably covered in that class. So can we learn to create an AI entity as a different social platform? An AI entity. So do you mean by that like a different, will you learn to create like a different, yeah, so could you elaborate on that a little bit more? I want to make sure I'm answering your question. So there are like the discussion board, and we provide through Canvas tools to connect and socially connect with folks. But I get the sense that you're asking about creating an actual entity that that is some sort of service on one of those things. So yeah, on the AI entity is a difference. So could you just provide a little bit more detail? Happy to answer that. I'll go to the next question real quick. So just a little confused about Columbia and Emeritus. I understood this is a collaboration, but if it's run by Columbia, any reason this is not not via Columbia. Maybe Columbia doesn't have an online platform. Yeah, Columbia doesn't have, as far as I know, they don't have an online platform. Plus, there's a lot that goes on that we do. So like we actually do a ton. We built all the assignments. So like the actual lectures are delivered by Columbia professors. So they deliver the actual lecture, but the assignments are done, the webinars are done, the office hours are done, all the support is done from us. We provide you all of that. And so if you have a problem, you reach out to me as if you have a problem with the assignment, like, hey, this is not grading well, or I don't understand number 7, I'm the one that answers your questions on that one. So yeah, so that's what we do. We're in a partnership with Columbia Engineering. So building an intangible environment, self-regulating. Yeah, so in the AI section, we do work with like reinforcement learning that it deals with, and also like search and games that have some sort of agent that is behaving within some sort of environment. If you wanted to set it up as like a social platform, yeah, you definitely, there is so I think I understand what you're talking about now. So in graph theory is like a major topic that we cover in the AI course. And that's definitely a topic that we cover, is how this agent interacts, and training the agent to navigate this this environment. So that's definitely covered in the AI portion. You mentioned that you use an Emeritus proprietary platform. Does that mean we won't be using our own compiler like IntelliJ? So yeah, so there is, all of the assignments are hosted on the software is called Vocarium. And so that's where you'll be doing a lot of the work, but you can download it's just a Jupyter notebook running on a server. And so you can download the contents and use it, work with it locally in whatever environment you like. But just to have everything in one centralized place, that's where we use. Yeah, so we just use Vocarium to do the assignments, and then also to have our discussion boards and our lectures and everything. It's just in one website. It's called Canvas. Yeah. So how many assignments per week, I'm guessing, is the question here. So yeah, so in the applied machine learning class, there is one assignment every week, with one exception: the recommender system. That is a 2-week thing. In the artificial intelligence, there's one every other week. So those are sort of heftier topics too. So there's a lot of, the graph theory, like the math can get, it's not trivial. So the assignments are every other week in that one, but they tend to be a little bit longer too. So, okay, so covered some of the fees. Here's an example of a certificate once you complete. This is what it looks like. And that is my presentation. So I ended on time, which is a big thing for me. So that's good. I don't see any other questions. Or anything else you have for me? Perfect. All right, cool. Well, yeah, thanks for tuning in. And how can we get the recording? Yeah, so that is a question for, I guess, program support. I'm not sure. I think you've probably provided your email to join this, that it'll be emailed to you, a link or some instructions on how to access the recording. Is the classroom instruction at a set time each week? So no, the lectures are recorded, but my instructions are at a set time. So I have office hours that is at the same time every week. Those are also recorded. So if you don't have time if you're not available at that time, the office hours are recorded, and you can access that again through Canvas. And then the webinars are at various different times. So so in addition to the weekly office hours, we'll have like a webinar that's about, like, let's say clustering. and that'll be at a random, like maybe on a Saturday afternoon, perhaps. So it's just whenever they decide they want to host the webinar. So those are done live like this. My office hours are like this, and so the webinars. So. All right.